Hello everyone, welcome to Equal To, and this is episode 17 of our Polynomials playlist. And in the previous video, we have solved exercise 2.3 in complete. We have completed all the questions from that exercise. I hope you have watched all those videos right from episode 1 to episode 16. In this video, we are going to start the next section, which is algebraic identities. Okay, even in the previous chapter, that is number systems, we solved or we rather saw one algebraic identity, which was this one, right? X plus y into x minus y, that is equal to x squared minus y squared. I hope you remember that. Now in this section we are going to concentrate more on these identities, and we are going to learn a bunch of these identities, and that can be used to solve our problems, or it can also be used to factorize the polynomials quite easily. Okay, so those are the things that we are going to see. Now in this video we are going to see 4 of these identities, and we are going to solve one example question as well. Okay, so let me start with the first identity, and these are algebraic identities, right? So the first algebraic identity is x plus y the whole squared. Okay, so this is one of the most common identities that you can come across. You would have probably heard it somewhere in the movies or somewhere else, right? So you probably know this by now, but let us just cover it up and we'll see how it came to how did we come up with this identity. Okay, so the identity is x plus y the whole squared is equal to x squared plus y squared plus 2xy, or rather the correct way to write it is this 2 double xy, right? 2xy should be in the middle. X squared plus 2xy plus y squared, this is the preferred way of writing it. Okay, so how did we come up with this identity? Okay, how did we do that? Let us take x plus y into x plus y. Okay, so this is x plus y the whole square, right? X plus y the whole square is basically x plus y into x plus y. Now if you just multiply these two terms, right, this is how you multiply, right? So that is x squared plus xy plus yx plus y squared. Okay, so this is what we get, and xy is basically equal to yx, right? 1 into 2 is 2 and 2 into 1 is 2. It doesn't matter in multiplication and addition. It doesn't really matter, the the order doesn't really matter. So you can rewrite it as x squared plus xy plus xy plus y squared, and 2 times xy we have, so it can be written as 2xy. So x squared plus 2xy plus y squared. Instead of x and y, you can have a and b as well. So it can be a plus b the whole squared, which is a squared plus 2ab plus b squared. Both things are right. It basically is just an identity, and x and y are just variables here, so it doesn't really matter which variables you do make use of. Okay, so it's better if you can remember this in your mind, off the top of your head. If you can remember it, that would be very easy for you to solve problems. But in case if you forgot, or if you want to cross verify with yourself, you can try to do this derivation. Okay, you cannot even call it a derivation. It's quite simple. You are just going to multiply x plus y into x plus y, and that gets you this. But it's preferred if you have this in your memory. Okay, so that is how you came up with x plus y the whole square. The next identity that we have is very similar to the previous identity, except for the sign that we have in between. X minus y the whole squared is the second identity. Okay, so I'll just make a couple of changes in this, and that will come up to that. Okay, so x minus y the whole squared is x squared minus 2xy plus y squared. And how did we derive that? The same process. Okay, instead of x plus y into x plus y, we are going to multiply x minus y into x minus y, and that is going to be x squared. This is x squared, right? And this is minus xy, and this is going to be minus yx, and this is going to give you plus y squared, right? Because minus y into minus y is going to be plus y squared, because there is two negative signs. Okay, This can further be rewritten as x squared minus xy plus y squared, and that is x squared minus 2xy plus y squared. Okay, so that is how you come up with the identity, but again it's better if you can keep this in your mind. Okay, x minus y the whole squared is equal to x squared minus 2xy plus y squared, but this is how you derive it as well. Okay, moving on to the next identity that we have here, x squared minus y squared is equal to x plus y into x minus y. Okay, so this is something that we have already used in the previous chapter as well. It's quite a useful identity in that sense. Okay, we used it in rationalizing the denominator, right? I hope you remember that. Okay, now the way you come up with that is quite different from the other things that we have had here. Okay, so usually if we have x plus y the whole squared, that is x plus y into x plus y, right? And that we have it in our left hand side. But in this expression, we have this x plus y into x minus y in our right hand side. Okay, so that is what you are going to evaluate, and that is what you are going to bring it up to the left hand side. Okay, so x squared minus y squared, that is the identity that we are going to see now. That is x plus y into x minus y. Okay, okay then. So x plus y into x minus y. Again the same multiplication that we already did. So it's x squared minus xy, and here comes the interesting part, plus yx minus y squared. Okay, now while rewriting this, you will know that this is xy and this also is xy minus y squared. Since minus xy and plus y gets cancelled, you are left with x squared minus y squared. Okay, so that is how you come up with this identity, that is x squared minus y squared is equal to x plus y into x minus y. Again, the x and y really doesn't matter, you can have any variables that you desire. Okay, moving on to the next and last identity, that is, it's not the last identity for this video, this is going to be a last identity. So it's x plus a into x plus b, that is equal to x squared plus a plus b into x plus ab. Okay, so it's x plus a into x plus b. Now, if you might recall, we have used a similar kind of thing already. Okay, in the previous exercise, we have used it. Do you remember it? If you remember it, put them in the comments, I'll get back to you. If you don't remember it, please go and watch those videos first. Okay, so x plus a into x plus b. This again is going to be the same multiplication stuff. Okay, so that is going to be x squared plus bx. Again, this is going to be plus ax plus ab. And this can further be written as x squared plus a plus b into x, because in the next two terms you can have x as a common factor and plus ab. Okay, so that is how you come up with x plus a into x plus b is equal to x squared plus a plus bx plus ab. Now with this RHS, I think you might be able to remember. We have told, right, x squared plus sum of the zeros into x plus product of the zeros, while using factor theorem as well. Right, if you know the zeros of a polynomial, you can basically construct its quadratic polynomial, right? If you know the zeros of a quadratic polynomial, you will be able to construct the polynomial itself. Okay, I hope you remember this at least vaguely. Okay, so that is all the identities that we have seen in this video. Now we are moving to the exercise 11. Okay, we have another example as well. Okay, let me just see this first and we'll think if we can cover this in this video or the next video. Okay, so the first subdivision of this example is x plus 3 into x plus 3. Okay, so x plus 3 into x plus 3 is basically x plus 3 whole square, right? X plus 3 into x plus 3 is x plus 3 the whole square, and we know that x plus y whole squared is equal to x squared plus y squared plus 2xy, right? Or x squared plus 2xy plus y squared. Anyway, it's fine. So you're just going to fill in the values here. X is x itself and here y is equal to 3. Okay, so x squared plus 2 into x into, instead of y you are going to substitute the value 3, and for y squared you have 3 squared, that is 9. Okay, so x squared plus 6x plus 9, and that is the value. Okay, so what they are trying to tell is you can calculate the value, or you can rather evaluate this easily by using this algebraic identity. So the appropriate identity for this first subdivision is x plus y the whole square. Okay, moving on to the next subdivision, x minus 3 into x plus 5. Okay, so here these two are different numbers, so it can be x plus a into x plus b. Okay, now you might have one question. Okay, in the identity it is x plus a into x plus b, but in the question we have x minus 3 into x plus 5. How can we use this identity? It's quite simple. We can use this identity. You are just going to assume that a is equal to minus 3. Okay, so x minus 3 is basically x plus minus 3, right? This is x minus 3. So you are going to assume that a is equal to minus 3. With that you can use the same formula easily. Okay, you can use the same identity. Okay, so x plus a into x plus b is basically x squared plus a plus b x plus ab. Okay, so here x is x itself, so x squared plus a plus b here is going to be 2. Okay, a is minus 3 and b is 5, so minus 3 plus 5 is 2. So 2 into x plus a into b is minus 15. Okay, so x squared plus 2x minus 15, that is going to be the value. You can also find this by just multiplying these two x minus 3 and x plus 5, but here they want you to use the identity, and using the identity is quite faster, right? I think you can get that by now. Using the identities are faster. Okay, so that is the example that we have seen, and we have seen the 4 algebraic identities now. So if you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. We are going to be solving a few more examples from this subdivision as well in the next video, so stay tuned for that. Consider subscribing to equal to. If you have any doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.